In this example, we're looking at now translating each equation into a sentence. So we went from verbal to algebraic, now we're going from algebraic back to verbal. So there's kind of a simple way, and then there's a more convoluted way to write this down, but it's important to recognize that both ways are valid and both ways you should understand how to do it. So based on what this is, I can write all of the following. 7 times m minus q equals or is 23. I could write this a different way. I could say the difference of 7 times a number and another number is 23. So the difference of 7 times a number and another number is 23. I also could say 7 times m minus q is 23. Both are valid. One's a little bit more convoluted than the other one, but both you should recognize are a way to actually say this. At the bottom, I could write the following, that I have 3 times the sum of g and 8 is the difference of 4 times h and 10. Again, this is just one of the possible ways that I can say this. So we have 3 times the sum means to add, of those two quantities, is, which tells us it's equal to, that's the is part. And then we have the difference, which means to subtract, of the first thing that I'm saying, which is 4 times h, and the last thing that I'm saying, which is 10. Translate each sentence into a formula. So when we're writing formulas, it's important to understand that each formula is a algebraic representation of a physical situation. So you don't have to always draw it, but sometimes it might be nice. In this case, I'm not going to draw it, but I want to translate from the verbal to the algebraic. So we have 4 times pi, so we write pi, we're not going to write 3.14, times the radius squared is, and that's our equal sign again, the surface area of a sphere. So it's the surface area of a sphere. And that's basically like taking an orange and peeling the outside skin off and keeping it all intact. That's that. If we were to lay it flat and like count all the little boxes that make up that skin, that would be the surface area of a sphere if the orange is perfectly circular or spherical. And so when we're translating, we're basically writing a formula, and notice my formula has a equal sign, writing a formula to represent a physical quantity. Write a problem based on the given information. So in this case, they give us the variable, and then they give us a situation where they're using the variable. And so G is the number of gymnasts on a team, and 3G equals 45 is the situation that we have to come up with a verbal description for. So there are an infinite number of varied ways to do this. I'm going to choose to consider the following. So I'm going to say the gymnasts went for ice cream went for ice cream. I'm assuming many gymnasts don't eat a lot of ice cream because they're gymnasts. A gymnast went for ice cream, and each gymnast bought a cone for $3. The team spent a total of $45. And so if each gymnast spent $3 for their cone, and the total the team spent was $45, then 3 times the number of gymnasts equals the total amount of money was spent. And so these sentences represent the situation or a problem based on what this is. So to finish the problem, we actually have to ask the question, right? So we said what's going on in the problem, and then we set up the problem by saying what's going on, and now we have to say the following. And so you should be very used to something like this. Write a situation for the given word problem. And if you made a good problem, this could be used on a test. You can use it for yourself to practice, and you get practice in translating and trying to figure out how to write a problem based on the given information.